Hello students, welcome back. How are you doing? I hope you are doing good. So in this part, we will be discussing about the general methods of preparations of your aldehydes and ketones. Have you ever imagined how can you prepare your aldehyde or a ketone from alcohol or carboxylic acid? The answer is yes, there are certain methods of preparation. So yes, especially in this part, we will be discussing about how to convert different organic compounds with different functional groups like alcohols and carboxylic acids into your aldehydes and ketones. So why to waste our time? Let's start with this part. General methods of preparation of your aldehydes and ketones. So let's first discuss about the preparation of your aldehydes. So how can you prepare aldehydes? First important preparation technique is mild oxidation of your 1 degree alcohols, right? So if you have 1 degree alcohols and if you can oxidize it with certain oxidants, like if you have PCC, pyridinium chlorochromate, and in presence of CaCl2, or you either take Collins reagent, right? You just take CrO3 in turn pyridine, you can just oxidize your 1 degree alcohols. So you can see here you have 1 degree alcohol. For example, this is a 1 degree alcohol. So this 1 degree alcohol in presence of an oxidant like PCC, you will get an aldehyde at both ends. So yes, my 1 degree alcohols can be converted into aldehydes. So what is this? This is 1, 3, 1, 2, 3. This is the third position. So it is 1, 3 cyclobutane. And it is dicarboaldehyde, and in the previous part I have discussed how to give a naming for a given aldehyde. Next, reduction of acid, chlorides, esters and nitriles. So you have to reduce your acid, chlorides, esters and nitriles to get an aldehyde. The first point, we are actually oxidizing an alcohol. The second point, we have to reduce an acid chloride. So if you can reduce an acid chloride or an ester or nitrile, you can get back your aldehyde. For example, you have acid chloride, ester and nitrile, and you know what is acid chloride, right? In the beginning introduction I told what is an acid chloride. So it is RCOCl, ester is RCOOR, nitrile is RCN. So if we have this, you just reduce it, right? You have to just reduce it. And what is reduction? Reduction is nothing but addition of hydrogen. Yes, yeah, your hydrogen is getting added here. Your hydrogen is getting added in the aldehyde. So remember, you need certain temperature. That temperature is minus 78 degrees temperature and 78 degrees centigrade, and you use a reducing agent. So see here, it's a dry ice, right? So you know dry ice is solid carbon dioxide, and it sublimes at 78 degrees centigrade. So remember, this is a very important point. Only one equivalent of very cold DiBAH is used to avoid further reduction of the aldehyde to an alcohol, right? Because what is happening, there can be chance of reduction of your aldehyde to your alcohol. So if you have only one equivalent of your reducing agent, so what happens? It avoids formation of your alcohol. So you can only get aldehydes from your acids, acid chlorides, esters and nitriles. So reduction of acid chloride gives an aldehyde, but oxidation of alcohol gives an aldehyde. So recall that 1 degree alcohols, right? If you understand alcohols and you know what are 1 degree alcohols, right? So there is also another important concept that 1 degree alcohols cannot be oxidized to your carboxylic acids, right? Because alcohols, if I oxidize it, you will be getting aldehydes. Aldehydes, if I further oxidize, you will be getting carboxylic acids, right? And you can oxidize by using certain oxidizing agents. So here you have an oxidizing agent of chromium, HNO3, KMNO4, right? So aldehydes, 1 degree alcohols, you just mild oxidation. That means just minimum amount of oxidizing agent is used. That is nothing but mild oxidation, and as I told you, you will be getting aldehyde. And further, if you want to oxidize you will be getting a carboxylic acid. So I can say that aldehyde is an intermediate between your carboxylic acid and your alcohol. So these are the famous oxidizing agents, right? Either you take KMnO4, KMnO4 is a strong oxidizing agent, HNO3 or chromium, all this are strong oxidizing agent. So you can also get an acid. If you are not doing mild oxidation, there is a possibility of acid also. So yes, these are again other oxidizing agents like PCC, CH2Cl2, just as I already discussed in the previous slide. Also Jones reagent, here where you have chromium, right? Jones reagent is actually you will be having the oxide of chromium in presence of H2SO4, that is CrO3 in presence of H2SO4. So if you oxidize alcohols, you may get aldehyde and you will get carboxylic acid, and the reverse process is reduction, and if you reduce carboxylic acids, you may get aldehyde and you may also get an alcohol. And lithium aluminum hydride is a very good reducing agent available in the market. So in non-aqueous media, moderate to strong oxidants become mild, oxidizing 1 degree alcohols only as far as the aldehyde, right? So this is another important point. Next thing is carboxylic acids are difficult to reduce, right? This is an important point. So when I told you that you may get your aldehyde from your carboxylic acids, and how? Via reduction process. So carboxylic acids are difficult to reduce, and only reducing agents, right? You should have a strong reducing agents like lithium aluminum hydride, right? So the other problem with lithium aluminum hydride is that lithium aluminum hydride will not stop at aldehyde, but always produces an alcohol. That is the problem, you know. If we have a strong reducing agent like lithium aluminum hydride, instead of an intermediate aldehyde, you will be directly getting your 1 degree alcohol. So we have to keep in mind this important point. So several derivatives of carboxylic acids can be reduced to aldehydes under carefully controlled conditions. Yes. So you can still, there is a chance to convert your carboxylic acid into an aldehyde using carefully controlled conditions. I mean, you need a careful environment to convert this. So acid chlorides, so this is an important point again. So acid, chloride, esters and nitriles are reduced to aldehydes using very cold conditions. I told you, right, you need a controlled environment. So the controlled environment, nothing but you need a very cold condition, and remember, you need only one equivalent of reducing agent, which is, what is DABH? It is nothing but diisobutyl aluminum hydride, right? This is diisobutyl aluminum hydride. So if you can use those above considerations, you can convert your carboxylic acid into aldehyde, or you can convert the derivatives of carboxylic acid into aldehyde. So carboxylic acids can be reduced to 1 degree alcohols with lithium aluminum hydride, but no reagent. And this is already discussed point. But yes, you need a weak reducing agent. Yes, that's why DIBH is a weaker reducing agent than lithium aluminum hydride, and that's why you can use this to convert your acid into aldehyde. So this is also important point. DIBH is neutral, but lithium aluminum hydride is ionic. And not only this, DIBH is similar to another reducing agent, AlH3, and you have to remember that in the structure of DIBH, it is hindered by your bulky isobutyl groups, right? If you have an isobutyl group, and that bulky isobutyl group is hindered in DIBH. So only 1 mole of H is released per mole of DIBH, and that 1 mole of H is utilized for reduction of carboxylic acid to aldehyde. So apart from the preparation of aldehydes, next we move on to the preparation of ketones. How can you prepare ketones? So the same thing again, right? You need oxidation. Right? And now here I am not using 1 degree alcohol. Here I am using a 2 degree alcohol. So instead of oxidation of 1 degree alcohol, I am going for oxidation of 2 degree alcohol. So again, if you have a 2 degree alcohol, you need strong oxidants. You need oxidants, right? that oxidants, as I told you, KMnO4, you have H2CrO4 or HNO3, all these are strong oxidants. Now aldehydes, you need 1 degree alcohol, and for ketones you need 2 degree alcohols. So here you can see there is a 2 degree alcohol, right? This is a 2 degree alcohol, and that 2 degree alcohol in presence of an oxidizing agent, you will be getting a ketone now, right? Since this carbon is a 2 degree carbon, and you will be getting a ketone there. Next point. So next thing is Friedel-Crafts acylation. Yes, this is also an important point, right? In Friedel-Crafts acylation, you will be getting ketones when an acid chloride is used as an electrophile. And what is your Friedel-Crafts acylation? In Friedel-Crafts acylation, you have an alcohol. This is a phenol. Phenol in presence of your propanyl chloride, right? This is a propanyl chloride. And AlCl3. AlCl3 is a very important reagent in your Friedel-Crafts process. Either it is a Friedel-Crafts alkylation or Friedel-Crafts acylation. You will be definitely using your AlCl3. So you will be getting a 1,4-hydroxyphenylpropanone, right? Your propanyl chloride will be attached. Your propanyl group will be getting attached to the para position, because why? Alcohols are para-directing and ortho-directing, but para-directing is more stable than ortho-directing. Hydration of alkanes. This is an important point. So in this point, you can think that I can use my hydrocarbon to convert your hydrocarbon into your ketone, right? How? I have to hydrate with mercury, and you need an acid condition, and you will be getting an enol that automarizes to ketone. For example, you have one enzyme. That one enzyme in presence of mercuric acetate, you will be getting an enol form. Right, and you know about keto-enol tautomerization, right, where an enol form can be converted into a keto form. Yes, see, this double bond is shifted here, and then this will be shifted this side, and you will be getting a ketone at this position. So the important point from this is that I can get still my ketone from an alkyne. So this is a resulting ketone from your alkyne. So this ketone is a 2-heptanone. And not only that, your acid chlorides and in presence of lithium dialkyl copper, you may still get a ketone. And this reaction is very unique, guys. Why? Because the mechanism is uncertain, and you also know that we use DIBH for aldehyde reactions, right? Yes, we have discussed the previous slides that DIBH you can get aldehydes. So as with DIBH for aldehyde reduction, a low temperature solvent is used to prevent further alkyl addition to the ketone to form an alcohols. So that's why this acid chlorides plus lithium dialkyl copper is a unique reaction. Next, remember your carboxylic acid esters and anhydrous amines are not reduced by copper reagents. So since you use the lithium dialkyl copper, you cannot reduce your copper reagents, you cannot use your carboxylic acids, because they are not reduced by your copper reagents, because they are not reactive as your acid chlorides. So that's why you have a hexanyl chloride, and hexanyl chloride you can use a copper lithium, that's a Gilman reagent, right, which is dimethyl copper lithium. You can get a ketone. So you can understand from here itself that only acid chlorides reacts with lithium dialkyl copper, because other acid derivatives cannot be reduced by your Gilman reagent. Not only this, if you just recall the strong reducing agents such as Grignard reagent, right, and you know that Grignard reagent you can reduce an acid chloride to a ketone, right? So remember, you may get an alcohol, you may get a ketone, but it can be further reduced to alcohol. That is the disadvantage of Grignard reagent. Yes, you may get a ketone using Grignard reagent plus acid chloride, but after getting ketone, it won't stop the reaction. right? You may get an alcohol. And this is a concept check for all the techniques which we have discussed, all the techniques to prepare an aldehyde or ketone, right, from different components or different organic compounds. So just complete the following reaction by writing the major product. So what do you think will be the major product formed in this process? You have an alcohol, and you know that PCCCS2Cl2, you know that this is a oxidizing agent. Oxidizing agent in the sense it removes hydrogen. And the same thing, here also you have an alcohol. It oxidizes, it should oxidize that alcohol. And remember, the thing is, here this alcohol is a 2-degree alcohol. This is a primary alcohol. So think for this, I will be giving 10 seconds time. Students, think about that. This is a 2-degree alcohol and this is a 1-degree alcohol. So what happens if I oxidize a 2-degree alcohol and a 1-degree alcohol? Think carefully. So I think by this time you got the answer, right? So the solution is that the first process, you will be getting a keto group here, because alcohol will be converted into ketone, because it's a 2-degree alcohol, and 2-degree alcohol can be converted into a ketone. And here it's a 1-degree alcohol, and 1-degree alcohol can be converted into aldehyde. So the answer is, the major product in this is that you will be getting a ketone here, since it's a 2-degree alcohol. 2-degree alcohol can be oxidized to ketone, and 1-degree alcohol can be oxidized to your aldehyde.
So students, after going through the video lectures and video solutions, so you might be still having some doubts, right, related to a new theory or related to a numerical. So what you have to do is, just go to our website www.askIITians.com, and on the website just select the tab Ask a Question, and on the right side of the screen you can find Ask Experts icon. So on this icon just select your category. For example, if you have a physical chemistry question, and just post your question. Likewise you can post your organic chemistry question or inorganic chemistry question, and you'll be getting the solution and answer for your question within 24 to 48 hours.
So students, these are the different preparation techniques of different organic compounds to aldehydes and ketones. So these are the different important concepts for your IIT-JEE or APMT. Right? Why? Because you are able to produce an aldehyde and ketone from different organic compound of different functional group. Right? So I hope you enjoyed this part. And in our next part, we'll be discussing about all the chemical properties of your aldehydes and ketones. Till then, stay tuned to our sessions. Have a good day. Goodbye.